Well, welcome back to Mr. Rodder's Neighborhood. Today on Mr. Rodder's Neighborhood, we get down to some brass tacks somewhat on a project that, I've been kind of putting off on the back burner a little bit. The What If 300. It's got a lot of, comments and views on that. Going back to would a 350 Buick head fit on a 300 block, and what would it take? So I like taking the time to do this. You probably have a hard time hearing me because I got fans running, the air conditioner running, and everything I can do to keep it somewhat cool here in the shop today because it's so dang hot. So I figured, why not get into this 300 where I don't have to do any heavy lifting, some scrubbing, the whole 9 yards, and make it even hotter. I'm just gonna fit this together and see what we come up with. So here's what I've got so far. I'll get the camera flipped around and we will get started. Well, originally when I did the video, I had this 1965 300 block here on the stand, and now it's just kind of sitting off to the side. But I did have this 67 300 block sitting here that actually had a cam and stuff in it to make this a little bit easier. It has cam bearings to hold a cam. That other block would have required me putting cam bearings in it just to test some things out. So I figured I'd try this out. Now, nothing is in here permanent. It's all just really just sitting in here, mock up, the whole 9 yards. But so far what I've got going on here is just a used set of lifters that I'll probably just throw in the trash when I'm done. But I put the 350 Buick head on this side with the rock arm assemblies on it, the factory rock arm assembly. This is a 70 and later rock arm assembly. They used it to like about 73. They're low ratio. It doesn't matter. It's just meant for mock-up, right? Now the push rods are 7/16 chrome ollie adjustable big block Dodge pieces here. And the only reason I did that is because, one, they were adjustable and I could get them somewhat short enough to get the rock arm assembly on there. But also the 7/16 diameter kind of shows how much room and clearance there really is in the block with this head on there, and if it's even a possibility. And so what I did notice is there are some spots where it gets tight, like here, right? It's fairly tight. But remember, this push rod is about a 1/16 of an inch bigger than what it should be for running, like if it was in a running configuration. But because the big concern was the lifters were off 1/4 of an inch, blah, blah, blah. That's what everybody says. Won't work because the lifters are off and I gotta have, custom made everything to make it work. Well, that to me made no sense, okay? And I'll tell you why. When you're talking mass production engine, so from 64 to 67, this 300 block was in production. And really all they did to create the 340, which was the next engine in this evolution, was create a taller deck height. Then they went to the 350 Buick, which they bored it, and they put this different later 350 Buick head on there with the taller ports. And it kind of more or less mimicked the 455 of the day. And it carried over a lot of the characteristics that the 455 had. But it made no sense to go through and recast the whole entire block and move everything around just for a couple of lifter bores, right? If you're going to do that, why not re-engineer the whole thing? I mean, because you're literally changing your mold. So that got me thinking, how close is this really? So here we go. You can see the push rods are generally in a straight up and down orientation, right? Now there is a little bit of spread, and if you look at with this, I got this square carpenter square here. You can see where it is a little bit off, okay, but it's not something to really be concerned about. It's just these 2 center cylinders and these 4 lifter bores. Now, if you look at a 350 Buick, it's actually the same way. I had the 350 Buick that had the cracked block, and I decided to look at the lifters in that and the push rods, and they all kind of line up the same way. There's a little bit of spread here at the top. So that got me thinking, all right, well, the one thing that's going to actually show you what the difference is here and how far everything is off is the camshaft. because the lobes they'd have to be in a different spot if the lifters were in a different location. So I lined up a 350 Buick camshaft and I compared it to a 300 camshaft. So on the right here is the camshaft that was out of the crack block 73 350 Buick. The camshaft here on the left is a camshaft that's out of a 65 300, the hypo motor. So your Wildcat 355. Now I assume it probably has a little bit more lift and duration and all that jazz. But really what I'm looking at is lifter placement and where everything falls on the camshaft in regards to each other. Okay, so now I already know that the camshaft on the 300 Buick has smaller journals as it goes back. It gets smaller each time. Each journal is a smaller diameter than the front, right? So when you get to the front, that's the largest. It's actually the same size as the regular 350 Buick #1 cam bearing. And you go back to the journal on the second one, and it gets a smaller diameter than the 350 Buick, and it's even smaller than this cam this cam journal is the third one. Excuse me. And then the fourth is even smaller than the third, and then you get to the fifth, and it's smallest. The 350 Buick, they're all the same size all the way down, just like a 455. Matter of fact, it uses the same cam bearings as a 455. Now, if I wanted to put this camshaft in this block, there's a couple of ways to do it. Now, I could machine the 300 block to accept the cam bearings for the 350 Buick, or I could take a 350 Buick camshaft and just have the journals turned down to fit in the 300 block, which in my opinion is probably the easiest way to go, since this is all a what if, this is all a basic mock-up, and all this really is going to do is give me an idea of where and if this stuff is even possible without spending a pile of money, right? Well, here's something that's interesting. So you get the noses of the camshaft lined up, and I'm just using the edge of the table. So this is by no means exact, right? All I'm trying to do here is just get an even spacing amongst. So we already know that the valve arrangement on this first set of lobes, which is cylinders 1 and 2, is going to be the same. These weren't affected. The valve arrangement was the same on both the 350 Buick and the 300. It was when you got past the second cam journal here is where the valve arrangement changed. And now each one of them has their own valve arrangement. But if you look at the lobes, how far they are off, you can honestly see that the 350 Buick on the right-hand side is off by let's say a 1/4 of an inch. And it carries that through the second lobe. It's probably more like an 1/8, but we'll just say a 1/4 of an inch. Okay, it carries that through the second lobe. The third lobe, kind of the same. And the fourth lobe, kind of the same. All right, so what we do is we go over here to the block, and we say, all right, well, we were looking at the second cam journal back, right? And these things literally are off by a 1/4 of an inch. Okay, now is that a machining thing? Was that an improvement from Buick? What was it, right? Is it the valve arrangement? We have to have a definitive reason here for that being back. Okay, so you come over to the block. You look at the #2 cam journal, which is here, right? Okay, so your #1 cam journal is all the way in the front, and the thrust plate on the back of the cam is in the same place for the 350 and it is 300. So then you have your #1 cam journal and your #2 cam journal, okay? Now let's look at how the lifters sit in there. If I moved each one of these lobes back a 1/4 of an inch, would that impact anything drastically? Okay? Now, you see how tight it is right here from this lobe to this lobe? If I get my hand out of there and get a little bit of light down in there, you can see that this lifter on the third lobe back almost impacts the fourth lobe. So if you moved everything back a 1/4 of an inch or an 1/8 of an inch, would it really impact anything? Obviously, the lifter here is wider than the actual journal on the cam for the lobe, right? It's got to be the same way on each one of these. So you look at this one here, the first one on the second pair, right? Or on the first one on the first pair. So obviously it sits further back. Now if you move the lobes 1/4 of an inch, it would actually center it more on the lifter, okay, instead of being so far back. There's very little clearance between the lifter and the lobe behind it. Okay, so we get it over to the other side. You can see the lobes are not centered in the lifter. So if we move the whole entire 4 lobes back 1/4 of an inch or 1/8 of an inch, actually the only thing it's going to do is give us more room on this side, because they're not centered anyway. So now it's just going to give us more room. So is that really impacted? I don't know. But this is just me mocking up the block, right? Now you get back to this third set of lifter, or past the third cam journal in these 4 lobes here. It looks to be a little bit more squared up. Okay, so that means it could actually move front or back even a little bit, and everything would be okay. So we come over here and look at the third journal. All right, so here we go. 1, 2, 3, third journal. Let's compare the lobes. Now, instead of this, you know, like if you look at the second set of lobes here, this side was further back 1/4 of an inch. You look at this side, you look at the third journal, this side is a little bit further forward, probably like 1/8 of an inch. And it carries throughout the entire camshaft, okay? I don't believe that there's really any difference between the placement of these. All they did was refine the placement of the lobes on the camshaft for longevity's purposes throughout the years. And since all the lobes line up, or all the journals line up, I'm thinking I can probably just take this stock 350 Buick cam, turn down the journals here, and it will fit in the block without it really being anything custom. I mean, yeah, it would technically be custom at that point because it's a 350 Buick cam profile, but it has the journals for a 300, 340. Okay, even the 215. But I believe that I can probably turn those down and it'll fit in the block. Your lifters are going to ride on the lobes as they're designed, and it's not going to impact anything. And this will definitely work with using a stock profile. So maybe it might be smart if I just did, you know, essentially a 300 that was designed to be the way it was going to run, and then I did one with 350 heads on it using a stock camshaft, and then I can compare the two together and find out if there's any performance gains with this port. The other thing would be the only intake I have to work with for this configuration is a TA single plane that I have to cut up and weld back together. But I don't think, you know, of course, since it's a single plane, you're going to lose some of the bottom end torque, but you're going to gain a lot of horsepower up top end. And I think this port configuration is going to allow me to gain even more horsepower. So I think that's the number we're looking at here. But who could tell? But that's some food for thought for today. That's kind of what I'm messing with, just to see if anything's going to work or not work. And as you can see, push rods are pretty much straight up and down. So I don't know where anybody's getting it's way off. It's not really that far off. So until next time, I'll see you later. Oh, hey, and don't forget, we're having an event called the No Name Nationals, Sykeston, Missouri, September 30th, October 1st. It's at Jeffers Motorsports Park. You can pre-register on nonamenationals.com. You can even buy pre-registered spectator tickets on there. You'll save yourself $5 on the spectator ticket. At the gate, it's going to be $20. Pre-registered is $15 a day. So make sure you head on over to nonamenationals.com and get yourself enrolled.